So I'm Alex Tabarrok. You may know me from such videos as a price is a signal wrapped up in an incentive, and many others as well. Today I'm going to be talking about pollution. And look, we all know pollution is bad, no big surprise. The WHO and the IHME recently estimated that pollution, air pollution in particular, kills 6.5 million people every year. That's about 10% of all deaths. That is more deaths than from AIDS, malaria, and tuberculosis combined. But what I want to do today, actually, is to convince you that pollution, it's even worse than you think. It's even worse than you think. And I want to do so by talking about a number of new studies, a big literature which has come out in the last 5 years or so, which uses more credible methods and also kind of very interesting methods to show the effect of air pollution on things like IQ, productivity, and other things as well. So I'm going to begin with this paper, which is by Janet Curry and Reed Walker. And Curry and Walker want to understand the effect of air pollution on infant health. And of course, the key problem here is confounding variables, right? People who live close to areas of high pollution, they're not the same as those who live farther away. They're often poorer, they have different demographics, maybe different eating patterns, who knows? They're different in a whole variety of ways. So how do you know whether the deficits, if you measure some, whether they're caused by the pollution or by some of these other confounding variables? Now, Curry and Walker look at a very ingenious natural experiment. Okay? They look at the introduction of easy tolling, or fast tolling, or easy pass, which happened in New Jersey around the year 2000. And so some of you may remember, the toll plaza. Before Easy Pass, this was an area where the traffic slowed down. People have to take their money out, give change. Oh, I need change. Okay, I don't have cash, whatever. Okay, and you get a lot of pollution in the area near the toll booth. With the introduction of Easy Pass, most of the cars are just zipping right through, and the toll booth area has about as much pollution as anywhere else near the highway. So what they're going to do is they're going to compare the health of infants who were born, infants and mothers who were born near a toll booth before and after the introduction of Easy Pass. And since other things are changing over time, they're also going to be looking at a control group before the introduction of Easy Pass and after the introduction of Easy Pass. A control group which has similar dynamics to the treatment group, but is not near the toll plaza. To be precise, the treatment group is going to be mothers and infants who are born within 2 kilometers of a toll plaza. The control group is mothers and infants who are more than 2 kilometers away from the toll plaza, but they're still within 10 kilometers of the toll plaza, and they're within 3 kilometers of a major highway. So the idea is that the control group represents pretty similar people. They're all living near a major highway, and they're all not too far from the toll plaza, but the treatment group is within 2 kilometers. The control group is a little farther away. So they're going to do a difference in difference study. Look at the difference in the treatment group before and after, and subtract from that the difference in the control group before and after the introduction of Easy Pass. And so what do they find? So actually, pretty remarkably, just very, very simple difference in difference. They find that after the introduction of Easy Pass, the incidence of premature birth was reduced by 7.4%, and the incidence of low birth weight babies was reduced by 8.5% compared to what it would have been without the introduction of Easy Pass. Now, you can then add a bunch of controls, for precision. So you can do a regression and you add a bunch of controls for whether the mother was black or Hispanic, or the mother's education, the mother's age, whether the mother smoked or not, the infant gender, the birth order, the year, the month, the distance to the highway, a bunch of stuff. And you find essentially the same thing. Prematurity falls by 8.6 percentage points, and low birth weight babies fall by 9.3 percentage points after the introduction of E-ZPass compared to what it would have been before the introduction of E-ZPass. So really very large and substantial effects. And these effects of pollution, which impact a child in utero, they can last for an entire lifetime. So with low birth weight babies, it's possible, it happens, premature babies, that IQ may be lower and health may be lower. Even 30, 40 years later, they may be more likely to get a disease, to respond less well, to have other kinds of health problems. This is a big problem for dealing with a situation like this politically, right? Because the effects of pollution are widely dispersed, and some of them may not be evident until decades down the line. So it's very difficult to get a political, the infants don't vote, and when they're old enough to vote, they may not realize what the cause of their health actually was. Happened many, many decades before. However, one of the interesting things about a lot of the new studies on pollution is that these studies are showing that pollution can reduce physical and cognitive productivity now. So it's not just a question of health effects which show up many decades later. You can actually have contemporaneous effects on productivity. So I'm going to talk about this paper, a few papers. One of them is on call center workers in China, in Nantong and Shanghai. This is China's largest travel agency. And so they're call center workers, and what's interesting here is that the company pays a lot, monitors them really quite closely, okay? So the company knows the number of phone calls handled per shift. They know the number of minutes spent on the phone, the number of minutes logged on to the computer system, and so forth. So they have a really good, fine, detailed data on each individual worker's productivity. And the authors have a measure of pollution, which is based upon PM10, which is a little bit bigger than PM2.5, but includes PM2.5, which is a particularly serious measure of particulate matter. And they have this data for the city as a whole, measured from meteorological stations, which they combine into an air pollution index. Couple years of data. So what do they find? So what they find is a couple of things. First of all, the workers do show up on high pollution days, but there's a small but significant reduction in productivity. So each 10-unit increase in the API, there's a little bit worse pollution, reduces a worker's calls per shift by 0.35% and minutes logged onto the system by 0.25%. And both of these are effects which are measured from the individual worker's average productivity. So you have some workers who are very productive, they're a little bit worse off during high pollution days. You have some workers which are less productive, they're also a little bit worse off during high pollution days. A 50-point increase in the API, just like a standard deviation, so it's not uncommon in this part of the world, would reduce productivity by something like 1.5 to 1.25%, 1.75 to 1.25%. Now, you might think, well, that's not such a big deal, 1%, 1.5%, even 2%, not such a big deal. But remember, they're measuring the pollution at the city level. So if these workers at the travel agency essentially clerical workers, if these workers are representative of workers in the city as a whole, you're talking about reducing the productivity of millions of people by a little bit, 1%, 2%, okay? But that kind of number adds up very quickly when you're talking about reducing the productivity of millions of people. Some nice robustness tests. The negative effect of pollution is concentrated on the day in which the pollution occurs. You don't see it happening on previous days, and it doesn't seem to last much beyond the day on which it occurs. It occurs for both the effect on the number of calls and the effect on minutes of the call as well. Here's another study. This one is on garment workers in India. And in this study, they actually have pollution monitors in a factory, which monitor from hour to hour the amount of pollution which each individual worker experiences. And there can be differences across the workers because of the way the factory is located and the air is kind of coming in from the wind and traffic is going by, things of this nature. So they have variation in the amount of pollution which each worker experiences within the same factory. So they asked, what's the impact of a 1 standard deviation increase in pollution on an individual worker? It's a decline of 0.8 percentage points, which is about 1.6%, for 3 to 4 hours after the shock, with larger effects on the older workers and on tasks which require more skill, more close sewing work and so forth. And you can actually see this. So this is when the shock occurs, okay, time 0. Not much is going on before that, but after the shock happens, then you see the decline in productivity, which lasts for about 3 or 4 hours. Chess players. This is one of my favorite papers. It's a very cool paper. What these guys do is they look at the measure of the air quality at chess tournaments in Germany. And so they have different bunch of tournaments, okay, series of chess tournaments. And some days the air quality is worse than other days. And they compare the moves which the players made with the moves that they should have made according to the world's greatest player of chess. So did they hire Magnus Carlsen to tell them what was the correct move? No, I said the world's greatest player, Stockfish 9, okay, which has an ELO rating which is higher. They used the AI. So they asked the AI, here's the board. What should the players have done in this situation? If they did what Stockfish 9 said, then that was the right move. Okay? If they did something else, that was probably a mistake, according to the world's greatest player of chess. And what they find is that an increase of 10 micrograms per meter squared in PM 2.5, which is this small particulate matter, that raises the probability of making a meaningful chess error by 1.5 percentage points or 18.5%. So what we're seeing across a wide variety of workers, okay, is that a little bit worse air pollution, and people are making cognitively, they're having a little bit of a cognitive failure. Okay, they're making worse decisions, whether it's answering the phones, or whether it's a high cognitively demanding task like chess decisions, what move to make. And you can think about it this way. If I ask you here, I guess I should have done an eye clicker. Which person is sick? Okay? Is it the person on the right or the person on the left? Ends up if you think the person on the right is sick. Ends up if you think the person on the left is sick. So you can tell, right? You can tell. And yet if I ask you why did you say that? why do you think the person on the left is sick? It's a little bit hard to say, right? It's hard to, something about the color is a little bit different, the eyes are, slightly less bright in some sense. Kind of hard to exactly identify. And yet almost everybody was able to do it, right? Okay, you're able to say that the person on the right is okay, the person on the left is probably a little bit sick. And that is how you should be thinking about the effects of air pollution, right? So I think we all know, we all have some days, right, in which we're just a little bit off. We have the sniffles, we're just not feeling, we're at like at 95%, we're not at 100%, we just don't feel as sharp, as quick, okay, as we normally do. And it's that kind of effect which pollution has on people. And notice, again, to feel that you're a little bit off and so forth, you'd probably not assign these subtle effects to pollution. Okay, you probably would not say, it's because of the air pollution that I'm feeling a little bit off today. And yet this happens. And these kinds of effects are subtle, but they're real, and they add up. There's a bunch of these papers. So my rule is always to trust literature, not papers. And so there's a huge number of these papers, or a large number of these papers, increasing rapidly. So there's papers on from Israel, showing that people who take the national college admission test on a high pollution day, they tend to score lower, with long-run effects on their careers. If they don't get into a top university, they're just a little bit off. There are papers on schools in the United States which show that students who transition from a school that is upwind of pollution to one that is downwind of pollution see a decrease in test scores and an increase in behavioral incidents and absences from school. Another paper finds that when a big factory closed down, this was a paper from Mexico, it's a big local polluting factory, they find that workers who lived in the area but who didn't work at the firm, they increased their hours of work. Many, many papers along these lines. Now, a lot of these papers, as we've been discussing, are dealing with Europe, the United States, okay, a few with India and China and so forth. But a lot of them are showing that pollution has these subtle but very real negative effects, even at relatively low amounts of pollution, even at US and European levels of pollution. If you look at India today, which is one of the most polluted countries, the air pollution problem is one of the worst in India, even more than in China nowadays, especially along the whole Gangetic plain. You have much, much higher levels of pollution. And so one can imagine, or it doesn't take much to imagine, that the effects on productivity at higher pollution levels are considerably larger than at US or European levels. In fact, one study, a paper by Greenstone and co-authors, they estimate that reducing air pollution in India to the Indian National Ambient Air Quality Standard. So there are many regions in India where the pollution levels are above the Indian standard. If you reduce pollution levels to the Indian standard, that would add 3.2 years of life expectancy to 660 million people for a gain of 2.1 billion life years. And that is an incredible number. It's hard to wrap your mind around that number, because even if you use the value of a statistical life in India, not the US level, the Indian level, adjusting for GDP per capita and so forth, that means that there's a potential gain of 4 to 10 trillion US dollars, okay, if you could eliminate that pollution and increase life expectancy accordingly. And the Indian standard is well above the Chinese, European, or US standard for air quality. So the way I kind of summarize this is that we should be thinking about pollution as an attack on human capital. So it's like we're spending all this money like raising people's human capital, educating them, giving them experience and so forth, and then pollution is like an attack on human capital, like a rust, okay? Reducing our human capital infrastructure. So we're seeing pollution reduces health, that exposure to pollution in utero can have lifelong effects. Pollution reduces labor force participation. Pollution reduces productivity. Pollution reduces IQ and disrupts behavior. In short, pollution is an attack on human capital. So much so that my view, okay, is, we used to have this story. I call it a story. Okay, it's a very plausible story. Larry Summers once wrote a controversial email making this point, which is that, poorer countries, developing countries, they have more pollution, but that's probably efficient because they have lower GDP and, Maslow's hierarchy of values and so forth. It's a decent trade-off. That's a trade-off which, if you're particularly poor, you may be willing to make the trade-off of higher pollution because you have other problems. You got more immediate problems to deal with. The idea of this view is that clean air was sort of like a consumption good, like a granola or dances with wolves kind of thing. It's a good thing, to have, but that's something which rich people have. Okay, so that we want to consume as we get rich. We can buy this thing which is nice. It's nice to have, but it's nice to have in the same way that a nice car is nice to have. It's something you buy when you're rich. You buy nicer clothing, you buy a nicer car, and you buy nicer air. Okay? Pollution, less pollution was a consumption good. And I think what all of these studies about pollution and productivity are indicating is that actually we may be in the double dividend region. That it may be that actually on the margin, you can have less pollution and more GDP. And more GDP. So we are here as the argument. Less pollution, more health, and more wealth. And that's kind of a remarkable change in the way people are beginning to think about these kinds of issues. So let me just conclude with a few remarks on teaching. Okay, pollution, of course, is an important externality. So it's a good thing to teach for that reason. It's also a chance to teach difference in difference method or other fun and interesting natural experiments like the chess natural experiment. I think students are pretty interested that economists are talking about infant health and they're using all of these downwind of pollution and upwind of pollution and all of these kind of clever natural experiments to untangle the causality. That's pretty interesting. It intersects with development economics, as we talked about. Okay. And there's some resources. Anybody who wants these PowerPoints, in fact, I have a little bit more extensive PowerPoints because we only have a short time today, are certainly welcome. It's in Modern Principles of Economics, particularly in our next edition, but there's some in this edition as well. And there's a video, okay, which you may see me in, okay, which is an MRU video. This is a clip from the video. You saw the difference in the toll booth and the treatment group, so you can get a mini version of what I've just spoken about in this MRU video. So thank you very much.